each one of you. We will talk about the protocols involved in Internet of Things. The outline of my presentation would be like introducing onto the topic of discussion, then some standard IoT protocols, the protocols used for different purposes like consumer-based application, industrial IoT. Then I will finally touch upon the 6th generation, so that it tells us regarding the future protocol and its relevance. In fact, what we present today are supposed to be a bridge between our past and what we expect to do in the future. So this will drive the product development. The past will drive the product development. The future will drive the research. So that's why I will also stress upon the future generation 6G protocol, and I'll also give some idea how to choose a protocol for a given application of your project or product or any system where you want IoT based solution. Then we will have a conclusion of the things. I would also love our interaction to be, or these presentations should be more interactive. Rather than one way, it should be bidirectional. So first, I will give a vision of the IoT market. See, if you see the regions that are green is having a very high growth rate of Internet of Things market, and where we fall into, India falls into this region. So this is the first driving force behind why we should concentrate upon IoT. If you see, the growth is very low in these regions. These are in African regions, the South American regions, the growth is high. Other places is mid. Maximum growth is in this region, and we totally fall into that region. So this is for only 2025, and we will target towards 2030, where 6th generation mobile communication, cellular communication will be into force, and that will lead to a good development, or that will better cater to the development in the IoT market. So first, when we have, I'm sure you must be having a good knowledge about Internet of Things. So there will be any animate or inanimate object which we want to connect to the internet, so that we can have remote accessibility, remote controllability of the things. So when we talk of remote accessibility and we talk about remote controllability, then there has to be a secure, a reliable, established communication between these. The communication has to be, it has to be point to point, point to multi-point, it has to be machine to machine. Different ways the communication can happen. If you think of a typical IoT application scenario, generally we see two communications into force. One between the sensor node, which is attached to any species or anything that we want to control, observe, or monitor. So between that to some serving end. Serving end can be a space where we store the data or where we run our algorithms for decision, and then from that serving end to the client. So you have one is sensor server communication, then client server communication. The people who are in the computer science background, they are very much aware of this client server network. So client server is there, and a lot of clients are there. So we have today we have multi servers and multi clients. So there is a concept of floating server. So floating server, somewhat people call it as a cloud today. Cloud is it's a server to store, to compute, to put intelligence into our system, and then less things are done actually at the client end. So that's what the system. When such a communication is happening, then the communication has to be fast, it has to be reliable. Second, it has to be secure. So these two are very important. And that is why this course has been designed to tell the security aspect of the communication. So when there is a communication, there has to be a protocol. Then you may say that when two devices communicate to each other, why there has to be a protocol? That you must first understand. A protocol is is a way to standardize the communication. Standardize means if both the fellows abide by the protocol, there won't be any loss of information, there will not be any breach of reliability, and of course, there will be security in force. So, the protocol is nothing but a set of rules. If we try to understand what is a protocol, it is a set of rules that both the communicating parties must abide by. Now we'll see what is the we have to have so uh, our capability to have more number of devices requires a standard protocol should be followed so that we can have scalability. What is scalability? Scalability means suppose I design a system, I design IoT sensor nodes. So I first design in my prototype for one or two nodes, then try to establish the communication between that one node and the server, then server to the client, then second node to the server, server to the client. But when I have uh, a distinct protocol, then seamlessly I can have n number of devices designed and developed and then integrated into the system. Then so this makes the system scalable. I have to add only devices, giving them IDs, and then start working with the system of which we call as a IoT based system. So what is the requirement of IoT protocol? We want quality, we want credibility. So this is being offered by our communication standards. And of course, when you have a protocol in force, then the system becomes robust against the external interference. So again, also we have a security in the transmission, of course. This we require to cater to the massive IoT requirement. Now you see, if you today you see uh, some 20 years back, cell phone was a dream to people. It was only selected, you can count people in your fingers. So those were the people who are using. But today, even if he is street vendor, or even if a agricultural worker is having a cell phone, not only a cell phone, a smartphone with him. So that's how the people are getting connected, and that has created huge traffic, and that has also created a lot of mess in the system. Now you think of a scenario when my table gets connected, my printer gets connected, my light gets connected, my you can say everything. My refrigerator gets connected, my TV gets connected, my door locking system gets connected. Every inanimate species are also getting connected to the internet for some purpose or other. Then there is a massive requirement of sensor nodes, IoT sensor nodes to be deployed, and they have a requirement of massive communication with proper standards and with all those requirements that I've told. So that is one requirement. Second is interoperability. See, it's not like that somebody has manufactured one device and somebody else cannot put it in his own system. So people, there will be multiple vendors who will have their own devices, and there has to be standards. Just like you think of, there are many companies who are selling pen drives. You know, ScanDisk is selling, HP is selling. You name the company, they are selling pen drives, and all the pen drives you can put in any of your laptops or computers. How it is possible? It is possible because all of them adhere to the USB standard. So similarly, even if we have different or divergent IoT sensor nodes, if we do not put a standardized protocol, then we cannot scale, or we cannot have multiple options for working. When such is the large market, such is the large place of deployment, we would definitely like that multiple vendors will be there into operation, and there should be interoperability things available with that. So there will be many of the self hardware like gateway chipsets will be there. Many commodities will be there which can be programmed through different systems, and they have different standard protocols. So interoperability and giving the flexibility of innovation. So keeping rest of the system intact, the part of the system to which somebody is working, there should be sufficient amount of flexibility for innovation to improve the performance, to improve the quality, to improve the price. So this can only be ensured if we have a standard protocol through which things are connected. And of course, I have told you regarding the global scalability that creates a necessity for standardization or protocols. So you can visualize IoT as a network of networks, just like people call internet. So here you see many domains, and future all the domains are claiming to, or are demanding to be interconnected, to be linked. You can say education getting linked with home, business, energy sector. There is transport. Everywhere there will be connections, and many others will be there, of course. So these networks will be connected, and there will be requirement of security. There will also be requirement of analytics. Analytics means doing analysis on the available scenario, available data. So helping us to take decisions, helping us to reject the unwanted stops. Many things are there, and we also want to enhance our capability to manage such a huge network systems. So thereby IoT is becoming more challenging, and all these networks has to be standardized. So a lot of standards are available, and let's look at the protocols of IoT. You'll find there are data protocols, there are network protocols. So basically, what are network protocols? Network protocols will connect our medium to high power devices over the network. So you have network protocols that will permit the data communication within the scope of the network. So like we have HTTP, you have LoRaWAN, Bluetooth, Zigbee, so like that. Then in data protocols, so where low power IoT devices, and actually they are the field workers, they will collect data. So most of the times they are not having the net connections. Of course, they can have net connections. If you think of a scenario like, let's say, if you think of a scenario like a metropolitan city, or if you think of a scenario where good connectivity is there, there we can afford to have some set of standardized communication interface. But some places there is no availability of network. Let's say uh, somebody is working in a as a coast guard. So you have some marine, or you can say some ship which is traveling across the coastal region, keeping on monitor a strong vigilance over the security or other aspects in the coast region. there you will not find our standard communication cellular network being available. The importance is that IoT is glamorous only when it is wireless. So when it is wireless, if we do not have one, you can say one BTS, or you can say what commonly people call it as a mobile or cell tower. So we don't have such things available at all places, and so that the wireless being the last mile access, uh, wireless being the last mile access cannot be achieved. So in such cases, we create ad hoc networks. We create ad hoc networks which are locally communicating, then try to collect information through that ad hoc network, then uh, make the data jump from the ad hoc network to a standard network. So such things can be done through different communication protocols. So IoT data protocols are there, and then we have like our just like our HTTP, we have MQTT, QoAP, MTP, XMPP, some of the popular IoT data protocols that are used also. Let's see what is actually in the industrial IoT domain. See, industrial IoT is nothing but, if we think of industry like energy industry, say some power grid, or you can say some um, solar industry, or you can say some power plant is there, or you can say steel plant is there, or you can say some other plant like some nuclear plant is there, or you can say some chemical plant. So all these industries, they need to have IoT based data acquisition, and then subsequent decision making has to be there. When you can see in such cases, we can use the protocols like Bluetooth, Zigbee, LoRa1, then Z-Wave, Sigfox, Wi-Fi, then our cellular networks like 3G, 4G also they can be used. But sometimes, so these are the different, like you have Bluetooth is here, then Wi-Fi, then you have near field communication, Sigfox, Z-Wave, LoRaWAN, cellular, MQT, GPT. So these actually, apart from this cellular, others are mostly very local to that. This cellular makes it to internet. Others are, this is like Zigbee is a ad hoc network, Bluetooth is also a local, Wi-Fi is also local. When it is connected through a router to the other network, then we get connection. So, and what we plan in the future is 6G. Let's look at these protocols one by one, and then weigh its merits and demerits. So Wi-Fi, everybody is aware of Wi-Fi. You go to a railway station, airport, you go to a railway station. Just a minute. I need to take 1 second. Excuse me, please. Welcome back. Sorry for the interruption. Yeah. So we have Wi-Fi. Wi-Fi, all of you are very, we are very frequented with that. So it is based on IEEE 802.11 standard. The range of frequency is 2.4 to 5 gigahertz. Approximately, it caters to 50 to 100 meters and supports 600 Mbps maximum data rate. Commonly 100 to 200 Mbps it supports. And so it is, it's actually from Wi-Fi Alliance is there. So then Wi-Fi certified products that are there, which can be used for interoperability. And in fact, we have one UHF standard, which is 2.4, and then it's 5 gigahertz is SHF radio band. So in the Wi-Fi, all of you know that we have a hotspot or access point. So it has a range about 20 meters, so indoor, and up to 150 meters in the outdoors. It's there. And generally, there are many transceivers available which support this protocol. One of the popularly used transceiver is your ESP8266. ESP8266 popularly used. There are many others available also. It is a highly integrated chip which will offer a complete and self-contained Wi-Fi networking solution. The specs is that 802.11 BGN standards, then Wi-Fi direct point-to-point. Then we have an integrated TCP/IP protocol stack here. Then integrated TR switch is there, so low noise amplifier, power amplifier, and other things are there. PLLs, regulators, and digital controlled. You have crystal oscillator is there, power monitor units, and output power, of course, is 19.5 dBm in this B mode. So power down leakage current of less than 10 microampere is there. So this is that. So this is ESP8266 UART serial to Wi-Fi wireless module. See, so this is having again integrated TCP/IP protocol stack. Then TTL serial communication interface is there. Parameters are set by the AT commands. AT, all of you know, widely used in networking. So mostly smart home application where you can use through a Wi-Fi router. Your interface voltage is 3.3 volt. Then IO port package is SMD package. All I ports are laid out. Antenna is built in, and of course Wi-Fi is there 2.4 gigahertz. So you have the Wi-Fi SMD module CC 3000. It is from Texas Instruments. So it's another Wi-Fi module. It is again having wireless network processor, and then it will utilize SPI interface in contrast to UART interface. So SPI, all of you know, it's serial peripheral interface. I think people who are participating here are conversant about these standard things like UART, SPI. SPI, I can say it's you have a chip select, you have MISO, you have MOSI, and you have a clock. So these are the 4 line, just to recollect it. So this has the ability to associate with Wi-Fi access point using a cell phone application in the TI process called Smart Config. You can do. So again, it operates on 802.11 BG compliant Wi-Fi module, and it is IP version C4 TCP/IP stack with SPI host interface at 16 megahertz. So 2.9 volt to 4.8 volt with a current rating of 92 milliampere. So you can, of course, there are security aspects inbuilt into this. So this is also used in many applications. Then people use this Wi-Fi dongle. One example is this PC, do you know? It's a dongle, and in fact you can just it works through a USB port. This is a standard USB, all of you know. So you can, it has a CPU where it's we have a ARM Cortex S7 dual core is there. Then GPU is OpenGL 2.0. Then it's a dual core 1 GB DRAM. Onboard storage is there, 4G flash, micro SD card slot is there. Power requirement 2 ampere at the rate 5 volt DC. So API to access the different interface UART, ADC, PWM, GPIO, I2C. I think you know what is PWM and I2C, GPIO. So these are standard names in systems. Then, so this is again another ultra low power serial to Wi-Fi module with power amplifier. So it's compliant with 802.11b with data rates up to 11 Mbps. Serial to Wi-Fi embedded software will allow devices and apply manufacturers to easily add Wi-Fi capabilities to the products, and it will less impact on the host microcontroller firmware. So being Wi-Fi connectivity via serial host interface and also ultra power management, this becomes an attractive choice for the situations where we want a long battery backup. Also, this device is having a lot of security protocols in that, and so one of the most beautiful security protocol is enterprise protocol. Then there are different versions and generations of Wi-Fi. Wi-Fi starts here, you can see 0 version in 1997. Then here we are at 2020, so it's 6E, and we have this 7. So here the data rate is gradually increasing, and radio frequency is 2.45, 2.45. Again now we are thinking 6. 6 is also added. Yes. So, and devices, many people are designing ICs which cater to these standards, and these ICs are being designed by many companies, which can be seamlessly used by system developers for IoT based stuffs. Next one, all of you are aware of more than me. You know what is Bluetooth. No need to tell much about Bluetooth. Bluetooth travels through different standards. The operation frequency is 2.4 giga. Then range is around 50 meters. But of course, if you have a smart BLE, then data rates, of course, up to 1 Mbps is supported. Then I should not tell about Bluetooth much. So the modules are available. Many modules are to be standardly integrated with our systems. This is RN41. RN41 module. This module is a low power operation. It provides support for UART and USB data connection interface, onboard ceramic chip antenna, 3.3 volt, baud rate is 12 bits per second, and then up to 1200 bits per second to 921 kilobits per second. So it is encrypted for 128 bits for secure communication. Then error correction for guaranteed packet delivery is also there. So the Bluetooth module, another is there, SC05. SC05 is it's again Bluetooth version 2. Then with enhanced data rate, we have 2.4 gigahertz ISM band. I believe all of you know what is ISM band. It's used for scientific and medical purposes. Then the modulation it uses is GFSA, Gaussian frequency shifting technique. Emission power is less than 4 dBm. Then Its power supply is 3.34 DC, 50 milliampere current draws, working temperature is minus 20 to 75 degrees centigrade. Dimension is this. This can be used in many of the applications. Next, coming to the protocol of ZigBee. In fact, ZigBee is a very strong protocol, and the alliance of ZigBee is very, very strong across the globe. Many companies adhere to this ZigBee alliance. They join together to make a good standardization for ZigBee. The beauty of ZigBee is that the network that it can create a mesh network very nicely with capacity of being hopping. Each node in each ZigBee node itself can work as a hopping point for establishing a communication between two different nodes. So that's how, and ZigBee variety standards are there, ZigBee Pro, so many standards have come up. ZigBee 3.0 is based on IEEE 802.115.4, and again it uses this 2.4 gigahertz frequency. The range of this one is nearly 100 meter, of course, 100 meter. The data rate is 250 kbps. But ZigBee Pro provides better data rates with better. The ZigBee protocol, you can see, you can have a mesh like this. These are all ZigBee nodes you can think of. One ZigBee node, another node, another. So these are different ZigBee nodes, and some of them can be the ZigBee coordinators. Some of them are routers. Some of them are ZigBee end devices. So you can say the coordinator, in fact, coordinator is something like a master, which is it's like a master, and then these are the routers which simply work as a hopping point. Data is coming from here to here, here to here. So this is a router, and this communication is of course wireless. These are all wireless communications. Please understand, wireless communication. So these all links are wireless, and here there is a hopping possible, so we call it router, and this is again hopping to this router, then here to here, like this communication happens. So ZigBee will have a low power consumption. The best feature of ZigBee is that it provides very high security. Also, it's robust, and you can have a good amount of scalability with ZigBee. Scalability means this is a very small network that you can see. You can drag it in any direction and add many nodes, many more nodes to this. So mostly for industrial sites it is used. Of course, it can be used for consumer applications, but most popularly it is used for industrial applications. You have one industry. So let's say the industry like steel plant is spreading over a length and breadth of, say, I'll say some 5 kilometers. So 5 kilometer to 5 kilometer, something like this, just giving a typical large scale industry scenario here. So this entire region can be covered through ZigBee. If we have the advantage of line of sights, probably we will need less number of nodes. So we can flood the ZigBee nodes here, everywhere we can use. The advantage is that ZigBee is not wanting you to send its information to a public network. Let me give you some idea about the private network and a public network. Say cellular network, your cell phone. I have a cell phone. How do I access? How do I access something in my cell phone? I connect to the nearest BTS through a wireless link, and BTS, this is the standard network here. If I have a sensor here, I have a sensor, this sensor has to be connected to this cellular network, then it has to be put to a public network. So public network will have access to everybody. Of course, we are providing security or encryption or authentication, or you can say the privileges to access to people only. But still then, once it's public, then it is prone to the threats of security. So that's what is public network, is a cellular network. But when you talk of Zigbee network, it has to be well within this Zigbee network. No need to send it to public network. So Zigbee is a private network, you can say, and this ad hoc Zigbee network is mostly used in industrial sites. Of course, another network protocol is being used for industrial, that's why LoRa-based application. So Zigbee protocol layers are based on the VLSI basic reference model. I believe all of you have the basic knowledge of VLSI because in your communication protocols, data communication, somewhere in your BTech, you must have studied that VLSI model. So Zigbee. So this is from the DG key, DG Zigbee 3 RF modules. So these are different RF modules where we have RF data up to 250 kilobits per second, and serial can go up to 1 Mbps. The indoor range is here 60 meter. Outdoor range is, you can say, 1200 meter. So that's why, of course, it is important is line of sight. If you miss the line of sight, it comes to 50%, 500 meters maximum. Transmit power is 8 dBm, and you have the interfaces like UART, SPI, I2C. The memory for this device is 1 MB or 128 KB. The protocol is Zigbee 3.0. Supply voltage is 2.1 to 3.6 volt. The transmit current is 40 milliampere. You can choose your application for suiting for the suitable environment by using the Zigbee, and I have seen it works very successfully for industrial applications where you don't have a general cellular network, or you do not want your industrial data to be available publicly through a cellular network. You want to only record it in your plant premises, or you want to take decision based on the data in your plant premises only. So this is again DGXB Zigbee. So this is like that. You can say UART SPI is there. So then there is it takes that Zigbee Pro 2007. You have DG Connect ports, DG Connect port X2 gateway. So where you have UDP, TCP, DHCP, and SNMP version 1. So this SSL tunnel and the ports is RJ45. So then you have power consumption. Idle mode is 1.2 watt, maximum is 3.4 watt. It is managed through HTTP. HTTP secure input voltage is this. So these are Zigbee status signals. Here is power, and this is what your Ethernet RJ45 on signal strength LEDs are of course there. Well, what I was trying to tell you is that Zigbee based communications are more reliable than cellular communication, which will come next. The reliability is so long as you are providing power to the Zigbee coordinator, and you are providing power to the Zigbee end devices and routers, you can expect them to be very reliable. Reliable in terms of not having failures. Most of the times, you know that you are going for a cellular outage. Cellular outage means, say your Jio cellular system is down, or BSNL, most of the times it becomes down. So this cellular outage will create hindrance in establishing a reliable communication. But when we talk of Zigbee, if you provide power to each of the node, then the communication will be sustained, will be reliable. No loss will be there, of course. And security is, of course, there much more than the cellular communication systems. So all of you are very much aware of the cellular networks. Cellular networks like you have GSM, GPRS, edge devices, UMTS, HSP, 3G devices, then 4G. All of you are using these things or you have used those things. And you can see the frequencies are 900, 1800, 1900, 2100 megahertz based on the region where you are operating. People tell that the range is 35 kilometer maximum for GSM. It's not actually true. You can't have a 35 kilometer. It's actually less than that. 3.5 kilometer, I would say. And for GSM, so HSP, of course, it has a little larger range. The GSM, once, see, this is what is your last mile access. Here you have a BTS. This is the base transceiver system, BTS, and here you have a cell. So this communication is wireless, and this wireless is typically 2-3 kilometers you can have. Data rate is was 35 to 170 kilobits per second, but with 4G you have much enhanced data rate where it supports video transmission reliably. Then cellular IoT protocols did not pre-established gateways to create a coverage areas. So that's what is very much there. But friends, one thing I can tell, if you are building an IoT based system, let's say IoT based surveillance, video surveillance system for some security application somewhere in a airport or a railway platform or some other public place, there you need to have a high-end video camera to be interfaced and wirelessly connected to the server. So here you need to have communication. We generally do it through cellular communication, no doubt, but of course other communications protocols can be used. But observe that here the data rate is pretty high. In contrast to somewhere some temperature monitoring through a thermometer is there, and you need to monitor server. I want to monitor the temperature of server. So it's only a very low frequency data. You can see temperature monitoring is not done every second also. People monitor the temperature, you can say 10, 15, 20 seconds like that somewhat. So even if it is 1 second, it's a very low rate communication. And but if you have a high quality video transmission, then of course it will have a high data rate. And cellular networks of course provide support for this today also. When we have 4G communications, and today our 5th generation is launched partly in the country, so that will have better capabilities. All of you know that benefits of cellular is that you have extensive coverage. You have to use a good backhaul network that is available, and it is one of the most cost saving application protocols. Cost saving in the sense that your background communication uh, network is almost there. You need not do anything onto that. It is highly supported, highly existing. You have to only use that by paying some nominal charges as you do in your cell phones. So then it is becoming better for remote management and flexibility in connectivity. So if we have 4G or LTE modem that can be used for higher bandwidth IoT application, we can also use narrow bandwidth IoT for low power, low bandwidth applications also. And security, of course, it is at threat, but still we can say security is there. That's how people we do. And most of the systems like agricultural systems, most of the systems like controlling the illumination in your streets, so such things they use this cellular communication. And this uh, cellular communication protocols are being used. Here, you know, that cellular is there 2G, 2.5G, 3G, 4G, LTE, 5G, you will add 6G next. Then wired system is spots. Spots means the plain old telephone system. Optical fiber, people used to use optical fiber. This is mostly used today, optical fiber. Ethernet is used in campuses. Then you have ATM frame relay. Uh, ATM is not that our bank ATM. ATM is your asynchronous transfer mode of communication, and frame relay is there. Then, of course, MPLS routers you may be knowing. Then power fine is another system is there. Satellite based communications, so satellite based C band, L band, of course Q band is there. Then short range wireless is like Wi-Fi, Bluetooth, GB. We have talked about that. Then low power wireless is WiMAX. In fact, this WiMAX was there, but it was not popularized. Wireless is, that is wireless interoperability for microwave access. And Sigfox is not that popular in India. LoRa is gaining its impetus. NB-IoT also. LTE-M is there. Then fixed microwave like VHF, people are very less they use that. Coming to development of the modules, IoT-based modules based on these cellular things, many companies are having standard modules, which are first we talk of the GPRS, GSM GPRS module. There is SIM 800, then SIM 900. These are the modules that are available for GPRS communication. You can see its antenna here. Through SMA connector, it's there. Then you have this one is the coding schemes that it is using: CS1, CS2, CS3, CS4. The transmit power is 2 watt per class, and so class 1 watt for some other class. Then GPRS, then control via AT commands. AT commands are there. AT means attention commands. So voltage supply required is 9 volt, 12 volt DC. So operating temperature is again 40 minus to 85. People integrate this one with the actual module is here. This is the actual chipset. SIM 800 chipset is here. You have a capability of putting a SIM card on this, just like it works like a dummy mobile phone. SIM 900 is also there. This is SIM 900 model. Then you have capacity forwarding SIM. This is one antenna available, internal antenna. Then we have external antenna also here. So yeah, so this is what SIM 900A. Many people use this, and there is RS232 DB9 connector is available here. So this is GSM based microcontroller projects. People use it. Then SIM 7600 EI. This is 4G LTE high speed modem is available, and it works on LTE. LTE stands for long term evolution. TDD means time division duplexing. Then LTD, FDD, frequency division duplexing, UMTS, HSPA, control via AT commands, TCP/IP. Then IPv4 and IPv6 both are supported here. And of course, we have DTMF and USB audio, and voice over LTE is of course there. So there is free optics. Then you have so this is again the modem that can be used. So this for development of IoT. See, when I am talking of use of these modems, I am showing the hardwares mostly, giving leveraging your thought that you know what is a IoT node. If I talk this as a IoT node, then I have partly as a sensor, which you have covered, sensor. Then I will have a signal conditioning for the sensor, which is mostly filter, amplifier, like that. Then we have a processor. So it's a processor, microprocessor or microcontroller, anything then like that. Then we have this communication protocol module. So this communication protocol module is there, and that's what we are talking. So this can be your cellular, this can be your Zigbee, this can be LoRa, this can be anything. So this thing can change, and giving it a wireless accessibility, or if you think of the optical fiber one, there can be fiber accessibility, but mostly it is wireless accessibility is there. Then there is a difference between industrial grade and normal things. What is the difference between industrial grade? Like sensors, we have basic sensors and industrial grade sensors. Similarly, the communication protocol modules, they are also normal modules and industrial modules. The difference between industrial grade and normal grade is that in industrial grade, they have to abide by certain standards. Industry is a place of pollution, a lot of dust will be there, a lot of moisture will be there, heat will be there, then roughness will be there, then hazardous stuffs, or there may be other gases which are there. So under such situations, my system should work. My stuff should work in all adverse conditions. So that's why we call it as industrial grade. Not only that, if you think of something to be deployed in our house or home, then it has a lot of security from environment. But when we talk of industrial grade, it is lying outdoor. It is lying subjected to a wide variation of temperature. Sometimes in the summer, the temperature goes up to 50 degrees centigrade. In the winter, based on the application region, it can go up to negative also. So our system should sustain that. There can be something like a lot of rainfall will be there, so humidity will be always 100%. Sometimes there is a dry area, there also it has to be deployed. So in such cases, we talk of industrial grade means it has to sustain through different harsh conditions. So that is why there are different industrial standards like IP67, IP60. Six such standards are there, which the companies they have to adhere before they declare that the product is industrial grade. So here we talk of this SIM 7600G H4G DTU as a 4th generation digital terminal unit development kit that is designed for industrial application. It will support GPS based. So you can see this is what is your GPS antenna. There will be USB to 4G communication, then 7 to 36 volt power supply. So there is onboard STM microcontroller unit. Then baud rate is 300 bps to 400 bps. Of course, it supports the AT commands. All of them are supporting AT commands for easy programming. Okay. We'll break for 5 minutes and I'll address to the queries if you have anything till now. If you have some queries, then please feel free. Okay. See, there are two things. Either you are understanding things because things are pretty easy, or something different is there?
Sir,
Yeah.
Acharya sir. Sir, actually their
Uh-huh.
mics are muted, but still they can write. If you want, I need to open their mic now. Means their mics and cameras are muted for attending.
Okay. They can write in the chat box.
Yes, sir. Actually, we used to open the mic at the last session last time, and they can ask directly. In between, they can interact in chat.
Yeah, they can interact in the chat box.
Okay, sir.
Okay, welcome back. I was just taking a break. We have a lot of questions here. I'll answer one by one. I have the first question from whom? Sunil Kumar sir. On what are the factors on which we can select type of nodes? Actually, this question is not clear to me. Ashkant, can you please unmute Mr. Sunil Kumar Sa? I'm not able to understand his question.
Sir, actually, we have unmuted all. They can unmute themselves and they can tell, I think.
Okay. So, Mr. Sunil, please explain me what exactly you meant by this. Your voice is not.
Mr. Chunil, can you please unmute yourself? Please try again.
Hello.
Yes, yes.
Yes.
Yeah, I'm Sunil here. Actually, sir, I wanted to ask that what are the factors we have to keep in mind to decide about the nodes, sensor nodes? That is my question.
Um, uh, to
Like
decide about the to design the sensor nodes or to
decide to decide the type of sensor
see,
node.
yeah. Let me. What I have understood is that from you, from your views, is that uh, see the type of sensor node, IoT node, that will be deployed purely depends on the application for which we are developing. Let's
Okay.
the case of I was just giving you a video surveillance system. So there, my sensor node is nothing but a video camera along with some processor, then some communication module. So that taken together, I can call it as a IoT node. But then
Okay.
if I am trying to record the continuous pulse of a person, so maybe some
Yes.
recording system plus one controller plus a communication module is my IoT sensor node. If I am interested to
Okay.
record,
Got it, sir.
yeah, so that's what. Then you have second question is from Krishna Chaitanya. Krishna Chaitanya, in fact, your question is on: is there any difference between industrial grade GSM module and normal GSM module in terms of programming or usage? See, in terms of programming, there won't be any difference. In terms of usage, there will be a difference. In terms of usage, like if you think of making a system for deploying in an industry, so or outdoor environment, then definitely that is a different type. And industry will give you all types of adverse situations. You just cannot think like something you are deploying on a road. Let's say you are monitoring the uh, conditions of a road, traffic conditions of a road. So that is different from an industrial scenario. In the road, uh, you have a very gradual variation. In industry, there are all. If you think of something to be deployed near the SMS or blast furnace in a steel plant, or in a coke oven near that plant, or if you think of a raw material place where a lot of dust, humidity, everything is there. So in such places, the lifetime of the sensor will be affected. So it is mostly usage in terms of lifetime, in terms of if it is exposed that much to air situation, whether it's performance will vary, or the different the performance of the different communication, connections, that will get hampered. So on that way it will be different. So in terms of programming, there won't be any difference. Then coming to Mr. Sandeep Kumar, how do we do the assessment of the security of the IoT protocol? See, actually, it's something like this. Generally, something like security is given only by knowing the threat type. If you don't know the threat type, then you cannot build the security. So it is something like antivirus. Antivirus is made by knowing the characteristics of virus. So when a new type of virus comes, if the procedure of attack is similar, then my antivirus can protect it. But if the procedure of attack is different, then sometimes it fails, sometimes it also protects. So sometimes it protects by the general rule. But if the attacker is smart enough that it attacks in a different way other than the general way of attacking, then my system is vulnerable to that. So assessing the security of the protocol, security of the IoT protocol is very difficult task. It's not that easy. Forget about IoT protocol, any system. Security of my cell phone, security of my computer itself, assessing what we are doing is it's a very ordinary security. But when there is extraordinary attack, then you have to address to that. So assessment is always it's a difficult task actually. So only when we know the type of threat and we inject that threat to the system and see that whether our system is vulnerable to that or not. So that's what we do. But if we don't know the type of threat and threat type has changed, then it's something open. So that's what I can say.
Yes, sir. Just I would like to further extend my question. Can I?
Yeah, please, sure.
Yeah. So, sir, is there any benchmark like we purchase a embedded CPU maybe or a desktop computer, so there is a benchmarking for that CPU. Like these are the set of programs, standard programs it will run, and it will give you some number quantifying whether the computer is fast, slow, or whatever it is. Now, my question is, sir, is there any benchmark, right? I mean, as you have told that you should know the type of adversary maybe or type of an attacker if you want to assess it. So there must be some known types, some known attacks, maybe as far as the IoT is concerned. So are there any benchmarks, some standardized programs which you can run over and you can comment maybe whether it is good, bad, or worst?
Actually, see, there are the IoT system is having threats from the attacks, whatever happens in a cyber system. So if we talk of the cyber attacks, like the phishing attacks or like your what you can say, there are different types of hackings also people do, and so there are different standard attacks actually are there in the cyber security domain. So the same also applies to IoT domain also, or so that's what I can say. But generally, what happens now? If people have a set of people know that what way people can attack, so they build security at the network level, they build security at the application level, at different levels they build security. Hmm. So sometimes like people use at the MAC level security. Sometimes people encrypt the network header itself. So different encryption techniques are used for like your advanced encryption schemes are used. So that's how you do. People do. And then network level security is also done. by protecting the message integrity. Then we have also application layer. There are different security mechanisms. People use different keys. Then people use keys. Then they protect the headers. They protect the payloads everywhere. So they use different keys in the network level, link level, everywhere. So you can say that. So
Okay, sir. Thank you.
In fact, see, you can augment your idea, because I am my research is not exactly onto the different securities in cyber or domain. So just I have a common knowledge about where the security system is built on. That's what I told you, like which layer, whatever layer we can do, and people where they can do network security, where they can do application security, what type of encryption. Those things are standard things that I know from common practice. But still, there are cyber security experts who know about the latest trends, how to handle the phishing attacks, how to handle different attacks. So they do that. So maybe you have to consult to some cyber security expert who can tell you the latest trends in the cyber threats. So that will be. I think one more question is there. You are Mr. Gajendra or Sandeep?
So you were talking to Sandeep earlier. I
Yeah,
don't know
yeah.
who has posted that one, but I was Sandeep.
Okay, fine. So similarly, Mr. Gajendra Kumar also has the same doubt, same question. Like then Sunil Kumar is asking the next question. I think he asked some question prior to that. Sunil Kumar Shah, yeah, he's asking how security protocol works. So that's what the question. I was also telling you that security protocol can be built in at different levels. So the level can be in the network level. So there can be network security. So network security can be done through encryption. So that's what a network level protection or encryption can be done. Then you can also have security at the application layer, as I was telling you. So application layer security, you can have different keys. Master keys will be there. Then there will be network key. Then link keys there will be there. So different types of. Then we use encryption standard. The payload, the message, everything can be encrypted through different standards. There are algorithms for encryption, like your encryption system algorithms, like advanced encryption system algorithms. Then there are other algorithms also available for encryption. Knowing those algorithms at the transmitter end, you apply that. Then at the receiver end, you decrypt that by knowing those algorithms. So that's what people develop security, so that it cannot be hacked or stolen, or something can be accessed in between. That's what is being done.
Yeah, thank you very much. I have got the answer for my question. Thank you.
And nowadays, of course, this particular program here, you will have detailed discussion regarding hardware security. So in the chipsets, different chipsets like your microcontrollers, or in your these devices, whatever we have, in those chipsets also we can build hardware security, so that they can be cannot be easily accessed or marked, like that. Okay. Fine. So if that's all, then we can start presenting once again. So my screen is shared, visible to you. My screen is visible.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay, okay, thank you. Now we'll start about the LoRa. In fact, today LoRa is getting good attention. So LoRa protocol. So LoRa protocol is, in fact, it's used in most of the industrial scenarios very frequently nowadays. It is not just like your cellular protocol. So all of you may be knowing what is the name of LoRa. LoRa stands for long range. So it's a radio communication technique and uses spread spectrum modulation, and the range is very high. So that's why long range. Long range means more than 10 kilometers most of the times. If you have good conditions, so LoRa technology generally it's very much used in industrial environment as a replacement to Zigbee, and LoRa uses very less power. That is one of the lucrative features of LoRa. And the LoRa also it was initially designed by Semtech company. Is there, and it is used for machine to machine and IoT applications too. And you can see it uses different frequencies. There are different standards in LoRa itself, and they use different frequencies. I told you more than 10 kilometers if you have a good environment, and data rate is also supported very high. Yeah, so it's very low cost mobile security to IoT, and then smart city industrial application. I've told you LoRa and LoRa wide area network together define the low power wide area networking protocol, LPW protocol. So it uses license free sub gigahertz radio frequency bands like 863, 873 megahertz in Europe. In India, they use these frequencies. So mostly LoRa is defined in its lower physical layer, upper networking layers, where so just like you have LoRa 1 protocol. So they define the upper networking layers. So it's a cloud-based MAC layer protocol, acts mainly on a network layer protocol for managing communication between LP1 gateways and end node devices as a routing protocol. It's maintained by LoRa Alliance. Many companies are there onto LoRa Alliance. You can see the LoRa module. So in fact, LoRa is targeted towards battery operated modules. It is using such a very low range that people can use for battery operated things, to the connection of this battery operated things to the internet. And so IoT platform is there, and it establishes communication both the way. And of course, the most important that it provides end-to-end security. So that's what is there. You can also have just like your Zigbee, the LoRa can have a star topology of deployment. Then okay, so up to 300 kbps RSSI. RSSI means received signal strength indication. So intensity, that's what is 127 dB. Wireless frequency is 433 megahertz. Operating voltage is this, and of course the standard working range of temperature is this. You see here, this is one LoRa. Here you have this is the module on which the capability of here is there. It's actually this one is your SPI. SPI is there, protocol, then general IOs are there, of course. So this is SX1276 LoRa module is there. It uses spread spectrum. That's the basis of CDMA. 868 megahertz, 8,000 meter means kilometer you can think. So there's a plug-in RF connector and UART is of course there. So shields are also available for that. Then coming to Sigfox, actually LoRa itself is a big topic. I'm just touching upon different protocols of LoRa. If you want, we can go into details of that LoRa. But then Sigfox is again another protocol where people use this. They use this 900 megahertz. So then range is similar or more than LoRa. Sometimes in the rural environment, some 30 kilometers deployment it can be there. In urban, 3 to 4 kilometers it's there, and so it's actually both. It's something like LoRa again with different capabilities. So there are a lot of similarities between this LoRa and Sigfox. The Sigfox communication, again, it is intended towards machine-to-machine application for low cost with low power consumption, and it is for communication of remote battery operated devices, again just like LoRa. So Sigfox system is designed to enable transmissions to cover long distances only with a limited number of base stations. It can be used like a cellular style. So remote Sigfox nodes can communicate with base stations which have internet connectivity. So thereby we can have a remote control and data collection from anywhere with internet connectivity. Means you can have a backhaul of our network. So Sigfox provides a low data rate connection for IoT applications. So if you are interested for using Sigfox as a machine-to-machine area of application, so you can have home consumer electronic application, energy-related application, healthcare monitoring, so transportation, remote monitoring control, retail, including point of sale and self-updating. Self-updating means something it uses the you can say in your retail application, some new device, some new commodity is put to the shelf or it is taken away of the shelf, then that can be done. But anyway, now with advent of computer vision into IoT, this is not being done through RFID-based or tag-based monitoring things like updating the shelves. So that's not done. Through computer vision, it is more intelligently monitored. Then, of course, it provides security. Then after that, Sigfox, there is a Z-Wave Alliance. It is used in many applications like home control to energy conservation. So approximately 30 meter range, very, of course, less range is there. Then it's a low power RF communication, mostly indoor environment. It is used and mesh network metrology. So Z-Wave based devices can attain a communication distance up to 40 meters with an additional ability of messages to hop between to 4 nodes. So Z-Wave provides applications layer interoperability between home control system to different manufacturers. So since alliance is there, many companies in fact make it interoperability. Okay, this is what is it's somewhat a comparison table. In fact, we have covered Zigbee, LoRa, Wi-Fi, Bluetooth Low Energy BLE. I have not covered this NB80 narrowband IoT. This narrowband IoT also gives a good range, nearly something more than the LoRa. Communication happens at a high rate, then power is less, star topology, then it's open. The best thing is that it's open property. It's there in the 3GPP standard also. NB IoT is there. Now I will come to the 6th generation things. Now this is what is a point of research. Why people what is the scope for doing research into fields of IoT, or what is the scope that IoT is going to see an immense growth in the future? That's because of this 6th generation. Today we are in 5th generation. So in 5th generation we have certain limitations. In 5th generation you cannot have a communication established. Just like I told, if you are inside a ocean, then you can't have a communication through 5G. Like only part of India where 5th generation is deployed, there only you can have communication. So wherever there is no deployment, so you cannot have 5th generation communication. That's what is the limitation of 5th generation. But you know, I have told you this is up to only 2025. By 2023, we are thinking that a world of things will be connected to internet. Like I was telling in the beginning, if in a home there are 2-3 persons, each one having cell phone, so we need the connectivity for 3 cell phones. But when it comes to things, we have some at least 20-30 things in a home to be connected to the internet. My refrigerator, my oven, my kitchen, my bedroom, my lights, my doors, so many things. So persons are less, but things are many. So that is going to that is going to create a huge requirement for IoT nodes. So by 2020 by 2030, so there will be you can say completely connected and intelligent digital world. So which will have impact on our socio-economic environmental systems, and this can be only addressed by 6th generation communication protocols. So where there will be terabit communication, terabit or terahertz communication systems, and quality will be very high and security will be very high, and everything. So when there is a lot of connectivity, everywhere there will be a threat. So security challenges are many. With increased mobile traffic capability and ultra low latency, 6th generation should be able to provide these features. And that's how we are growing in the protocol stack. We are in the landline to 2nd generation, 3rd generation, 4th generation protocol to 5th generation, and we target towards 6th generation protocol. So where we'll have healthcare IoT, we'll have vehicular IoT, means autonomous driving will be there. See, without proper communication, you cannot dream of autonomous or driverless driving. We will have a lot of unmanned aerial vehicles. Actually, it is visualized that these UAVs are going to play a major role in 6th generation communication. So UAVs will be something like, you can feel like drones are flying in the sky at an height of 2 kilometers just from the surface of the earth, and they are dynamically going. So each drone is working like a base transistor system or a best you can say BTS, it can work, and then it will dynamically adjust its positions based on the requirements. So then drone to communication will happen to satellite. So satellite communication will be there. That's how people think of, like, we are talking of satellite internet of things. Then we'll having industrial internet of things. All these things have the fusion of all technologies will be there. All communications protocols will be there to achieve a massive 6G IoT scenario, and that is visualized in 2030. So a research is required to cater to such requirements. And in each case, there is a threat of security which need to be addressed individually with advanced protocols, advanced mechanisms. And if the security protocol built in is becoming a load on the system, then that itself is a problem. So we have to think of lightweight security protocols. This is a comparison between 5G IoT and 6G IoT. 5G IoT data rate is up to 20 Gbps, and here it is 1 terabit per second. So here mobile traffic capability is 10 MB per second per meter square. Here is 1 GB per second per meter square. The connectivity density is 10 to the power 6 devices per square kilometer. Here 10 to the power 7 devices per square kilometer. Network latency is 1 millisecond. Here it is 10 microsecond. Coverage about 70%, coverage about 99%. Energy efficiency is 10,000 times more than 4G. Here it is 10 times more than 5G. So spectrum efficiency is 3 to 5 times relative to 4G. Here is 3 times relative to 5G. So you can see such a huge increase in the capacity of the system. And to achieve these features in the network, so we have to have communication enabling technologies based. We'll have here in 5G IoT, we have millimeter wave communication. Here we'll have terahertz communication. Here we'll have artificial intelligence is there. Here we will have edge intelligence. Here we have space, air, ground, underwater communication. You can think like you are in ocean, you are in land. So there will be ocean to land, then satellite. So everywhere, space, air, ground, underwater communication. Then there will be software defined networking like that. Here we are having today cloud or edge computing. There will have edge intelligence, and there will be reconfigurable intelligent surfaces, and blockchain will be a part of this, mandatory. So this is what is the requirement of 6G IoT, the systems. Then application domains will be like virtual reality, augmented reality, 4K, 8K videos, tactile internet, wearable devices, vehicle to everything, smart verticals in 5G. But in 6G, we will have holographic communication protocols. So protocols are getting redefined in 6G. It will be holographic communications. There will be 5 sense communications will be there. Then there will be fully autonomous driving, super smart verticals, space communications, deep sea communication. Space communications will warrant a different level of protocols. Deep sea communication will warrant another set of communications. So this is what going to redefine the IoT communication protocols. What are the necessities to start the study on 6G IoT? No, the first 1G system was in 1982. And what you can see is that a new mobile generation has appeared approximately every 10 years. So with that rate, 6G is expected to be 2030. So here you can say 92 is second generation, then 2002, beyond that we are getting third, then 2010, 20 we are now in 2010 to 20 third generation, then 20 to 30 so 20 we are in fourth generation, and 20 plus we are in fifth generation, and we expect sixth generation by 2030. So exploding potentials of new applications, like the stimulation of smartphones have led to the development of 3G and triggered the demand to deploy 4G. So similarly, IoT business is expected to stimulate 5G at some time during the 5G period, and then further stimulate the demand for future 6G networks. So the requirements of 6G IoT is that we need more stricter standards. This is where we talk of protocols. more stricter standards than 5G IoT counterpart to fully fulfill the 2030 Intelligent Information Society. So it will come with full intelligence, huge device connectivity, coverage, data-driven services, then autonomous systems. So there will be massive IoT connectivity, improved 6G IoT communication protocols, then extended IoT network coverage, then next generation smart IoT devices. These are the requirements of 6G IoT. Okay, so this massive IoT connectivity can happen through broadband access platforms as well as satellite networks, where you will use low Earth orbit satellites, and they will be the crucial enablers for part device large scale communications. And this again can be intermediated through the use of unmanned aerial vehicles. Okay. We have so extended network IoT network coverage will be there through this, and edge intelligence UAV. These are the important stuffs. Edge intelligence is what? When you are having one IoT node, so that IoT node is having a part as a sensor, then a part as a processor, then a communication. So a communication device. So this processor is capable of doing intelligent computation, and this IoT node is known as an edge device. So when we put artificial intelligence to this processor so that it dynamically handles the sensor data, takes important decisions, and also intelligently controls this available communication interface, then we call this as a edge processor or edge intelligent processor. And then communication will of course happen through unmanned aerial vehicles like your drones. So these will provide the full wireless coverage. So, so your 6G IoT ecosystem is giving more challenges for device development, device security development, communication protocol development, and communication protocol compliant security development, application of artificial intelligence to the edge devices, and of course a wide range of opportunities for doing research, for achieving higher you can say that for meeting the demands of the IoT world. So application services, architecture and management are all part of future 6G wireless systems, and everything will be controlled through your machine intelligence. They're both human and machine centric with more controlling options. 6G will offer immersive experiences and extremely smart verticals based on IoT. So 6G is expected to feature a number of novel technologies such as space, air, ground, underwater, seawater networks, and cloud technologies. So 6G vision can be summarized into immersive, ubiquitous, intelligent, and distributed connectivity. So that's what is the future of wireless systems. Now, coming next, yeah. Before answering this, I will tell you something regarding these protocols that you need to have. You need to have knowledge. Like when you are having these internet protocols, so you have HTTP protocol, you have MQTT protocol. So these two are very important protocols that's going on. So you have like your HTTP, all of you know, and MQTT, of course, many of you must have heard of that. That's a message queuing telemetry transport protocol. So this works on a concept known as your publisher and subscriber. And of course, here you have again you have a client and a broker, and then remote devices will publish that. So such protocols, these MQTT protocols, are becoming very lucrative for establishing the client server environment communication. So in MQTT, compared to your HTTP, MQTT is little lightweight, and many other advantages are there. So those are two. I felt like this HTTP protocol is well known to you. So I covered mostly the protocols where you need hardware stuffs, and this HTTP, TCP/IP, and of course the MQTT, which is today only mostly preferred IoT client server protocol, is your MQTT. So MQTT protocol is very important, and you can work with that, and most of the IoT systems work with that today. Now, coming to the question, some of you asked that which IoT communication protocol is best suited for your. This is what is to answer this question. We have to see what is our application scenario. Whether our application scenario is giving us seamless access to cellular network, whether I want to have ad hoc network, whether we want one ad hoc network to create ad hoc network, whether we want low power, whether we want a range, so how to have the connectivity. So such things only decide. Let us take case by case. If I am mostly interested in power consumption to be low with a relatively large area, but I want to have a private network, private ad hoc network, then my choice should be lower. If I want a connectivity across the globe, then my choice should be cellular. So this is just one example how to choose one protocol for our purpose. Now I will summarize my discussion by saying that in fact many communication protocols are there. Like we have not talked about much about this NB-IoT protocol, narrowband IoT protocol. Then we have NFC, near field communication protocol. Many are there. In fact, your NB-IoT is from that Nordic Semiconductors. So people work onto that. So you have NB-IoT means narrowband IoT. In NB-IoT, like you have deep penetration will be there, then there will be the cost advantage will be there, then there will be efficiency. We have compared that in the previous table, such will be there. So those are the protocols that are used for many of the applications where we want where our deep connectivity is also a concern. So then we need to have a deeper study onto each individual protocol to see the advantages, to see the volume of applications, to see the fastness of applications, to see the bandwidth. Like if you are trying to acquire a video data or image data or simply a one-dimensional data, so those things you have to look into that. So it is always better to choose an end-to-end IoT service provider that can provide seamless IoT solutions using all Internet of Things protocols. But then this is what is one company who will stand up making being an end-to-end IoT service provider. So because whenever we think of the user means customers, they cannot purchase part from this company, part from that company. IoT node service is being provided by somebody, then your cloud service is being provided by somebody, then the communication protocol somebody else has to give you, have to load it to your system. Such things are not possible. In fact, a company which has to provide end-to-end solution, he has to plan for the application scenario and define the required protocols, or use the required protocols, make the complete hardware and software solution, and then give it for the customer to be used. Now the IoT market is so huge that even if small companies who are monitoring only very simple parameter, let's say the level of dust in a given environment, just by monitoring that they are doing a lot of business. And we have lot many things to do in this. So when we have lot many things to do, many startup companies have a lot of scope. Only thing is that you have to fight for getting a business, sustainable business for that. So there you require, generally people jump into where there is a mandatory requirement of having monitoring parameters like that. So they are doing business into that front now. But tomorrow we need that most of the things will be mandatory even in the consumer environment. Now people think of industrial environment. Tomorrow it will be a common man's environment, while it will be required to have a IoT based system deployed. So there a very clean choice of protocol has to be there along with other developments, and this load of choosing the protocol and developing the end-to-end solution rests with the company who is trying to develop that solution. So either you can go for building a startup company, or you want to do a research. Then of course a lot of research is required in the area of security. As I told you, in the 6th generation, what we are planning in the future, there also we need a lot of research efforts to build up new protocols which has not come up till date. And protocols, friends, are built up by seeing the requirement, by seeing the scenario of deployment. So there are many criteria that are used to build the protocols. Of course, the IEEE standard, then ITU standard, then ETSI. These standardization bodies are working a lot onto bringing the protocols. Many companies, their semiconductor association companies, they are working together to build protocols for supporting the IoT environment. So this is what, in a nutshell, I could present before you regarding IoT protocol, and I would like to thank you for your patience in the odd hours. So I can invite some discussions, because I have visualized something which I presented for you, but I do not know whether I have met your expectations or not. So for that reason, I invite questions from you, so that the dais is open and we can discuss with that.
Thank you, Acharya sir. I have switched on the mic for participants, so we can expect 1-2 questions if. And then it's
now you switch on. We should have.
Yeah, it's switched on, sir.
Yeah, we should
At
have
the
a
last
lead.
towards the last, sir, we'll switch on the camera and we'll take a photo also. Now mic is on.
Okay. Please.
Hello,
Please.
sir. Can you share some resources where we can set up few experiments for students to do some practicals on edge computing?
See, basically, edge computing. What is edge computing? Edge computing means doing computation on the edge device. Now, in the edge device, the computation happens in the processor of that. The processor can be a microcontroller, a microprocessor, a DSP, a PG, or ASIC, anything. Now, when you want to set up edge computing application for the students, then it is good to start small algorithms like say some anomaly detection or for feature extraction of the data. If I am trying to, my IoT node is a edge node, I am trying to send only the relevant part of an image, or I want to send only the relevant part of a video, then I need to do a feature extraction. So a feature extraction algorithm running on a processor can be one of the edge computing algorithm. Or you can say an anomaly. See, I am monitoring the vibration of a motor. Continuously the vibration is monitored. So whenever there is an anomaly, whenever there is something which is disturbing, that can be analyzed in the edge processor, and that anomalous thing can be communicated. So thereby you can save the communication overhead. So that's what we do. So you can run anomaly detection algorithm, you can run feature extraction algorithm, you can run you can say some algorithms like this on different platforms. Like if you are interested in a PJ platform, you can do. In a processor platform, you can do. DSP platform, you can do. Choice is yours. So these three platforms you can choose, and you can choose couple of algorithms for computing and do it. So that's how the data coming from the sensor is getting processed through this algorithm, and then output is given for communication.
Okay, sir.
Is there any other questions?
Askant, if there are no more questions, I think we can stop it, and maybe a photograph has to be taken, and attendance, have they submitted through Google Docs?
Yes, sir. It is open. They are submitting it. Already 34 responses have been come.
Okay.
Acharya,
Then I
sir?
request everyone to please switch on your camera so that we can see you. And I must thank Professor Acharya to delivering a nice talk, taking on the protocols, defining protocols, and then talking in detail, and then going up to 6G and corresponding changes, and taking care of the students as well. So thank you very much, and let's time for a photograph.
So I request whoever possible, please switch on your camera. very less are there. We 3 only. Oh, it is disabled. Okay, okay. Sorry, I am making it. Okay, okay. Thank you for letting me know. Okay, I have made it on. Sorry, I made it on camera for all. Yeah. Okay.
Nice.
Yeah, large gallery view. Actually, we can have 39 at a time in MS Team, but okay.
You choose large gallery, then it will be more.
Yes, sir. Yes. 39. I think it's fine. Okay, sir. Thank you. Thank you, Acharya sir, Mahapatra sir, and all the participants. Tomorrow again we'll meet
Thank
for
you,
session
sir.
4.
Tomorrow we'll have a lecture on hardware security aspects, primarily on processor, and that will be delivered by Professor Anirban Sengupta. Is that right? If we are
Yes, sir. It is from IIT Indore. And tomorrow and on 26th also on security by Professor Urbi Chatterjee, IIT Kanpur. And day after tomorrow it is on fog computing. So some person was asking, so they can know about by Professor B.D. Sahu from NIT-Rourkela Computer Science Department. So cloud for IoT and fog or edge computing we will discuss on day after tomorrow. And about whatever PPT we received from experts, we will share it soon, and also videos. Okay, thank you all. We can join tomorrow at 6:55 p.m. Thank you.
Okay, thank you, sir.
Thank you.
Have a good night.
Great.
good night, good night.
Thank you, sir.
Thank you.